right, so welcome to Lab 4. This lab is on capacitors. It's called capacitive circuits, and you can see the opening slide here has many different kinds of capacitors that you'd see when you're working in the engineering field. The one that runs your air conditioner outside your house is this variety right here. It holds a lot of charge. So a capacitor, what it does is you hook it up to a battery, and then the battery pulls on the negative side, on the positive side, it pulls electrons off of a plate that's inside the capacitor. And then on the negative side, electrons stream out onto that plate. So the capacitor becomes equally charged, plus and minus. So when they talk about what's the charge on a capacitor, they're asking, well, what's the absolute value of the charge on one of the plates? And the equation that governs one capacitor is given by C, which is called capacitance, and it's how much charge you can put on those plates for a given voltage. And voltage is related to energy. So you see, when you start putting a lot of negative charge on a plate, the negative charge that's there is going to repel more charge being added. So in the very beginning, there's no charge on the plates, and so it's easy to put charge on. So charge streams out onto the capacitor quickly at first, and then slows down and slows down and slows down until it eventually becomes fully charged. Okay, and so once it's fully charged, the battery that's supplying that charge would be the voltage here in the denominator, and up on top is the amount of charge in coulombs, which we studied in the beginning of the course. Okay, and that ratio right there is the capacitance. Okay, so if you notice, if I double the voltage, I'm just going to get double the charge, because the capacitance is the physical thing. Once you build a capacitor, you can't change its capacitive value. Although there are some capacitors, like this trimmer right here. This trimmer allows you to change a capacitance by turning a little knob. And that's what the knob on your radio in your car does. So when you turn the tuner on your car, you're actually changing the capacitance, and you can tune into various radio stations by changing the capacitance of the circuit. We're going to study that much later, like lab number 10. So anyway, I can do a little demonstration for you. Like I said, this is like a typical air conditioning capacitor right here. This thing holds 25,000 microfarads, which means it will hold 0.25 coulombs for every volt across that I put across this thing. But I'm going to use a 9-volt battery, so when I get this thing fully charged, there'll be 9 times 25,000 microfarads, or 9 times 0.25 coulombs per volt. Okay? And so I'm going to hook this up. I got a little light bulb here so you can see the effects of what's going to happen when I put some power onto the capacitor. I got this already set up ready to go. This is so I could show you. And so anyway, here we go. I'm going to put the power on there, and you can see, boom, it was so fast you didn't even see it. So here, let me take it off, and we'll do it one more time. So now the capacitor is fully loaded with charge. So what I can do is I can take this lead right here that came from the battery, and now just put it right here and discharge it. So you see that? So a battery is a capacitor is kind of like a battery. But you can see it was really bright at first and then dimmed down. A battery's bright all the time until the battery runs out of chemical material, and then it goes down rapidly. But for the longest time, a battery's nice constant voltage. Here, we'll do it one more time. We'll charge it up one more time. And so let's see, I need to hook this up. So this is one side of the battery, and then here's the other side of the battery. So here we go. And that's it. You see, it stopped because you see the battery can only do so much work in separating the charge, and eventually putting more charge on the plate requires more energy than the battery's able to provide. So there's 9 volts across that capacitor right now. No more charge is flowing. So here we'll discharge it again. All right, so we take this and touch it right here, and it's like that. Now, what if I put 2 capacitors on here? So I'm going to add a second capacitor, okay, right there, and let's see, I'm going to put this on here, like that, and we are, and then I got to hook onto the battery here, and let's see, what side is that? Okay, good. All right, you ready? Whoa, that was really fast. I didn't expect that. Here, let me try to the other side. Oh, I got to discharge it. Hang on one second. So I'm going to discharge it right. So here's the positive here, all the way over to the other side. And you might even see some sparks fly. Nope. I think there was some there. Okay. So anyway, let's try that one more time. All right. Whoa, something weird going on here. Anyway, let's skip that. We're going to move along. Here, let me just do this one more time. I didn't see any sparks, so it doesn't look like. All right, hook that up here, and that was negative. All right, so this goes on to positive. All right, and we'll hook that up there. We're using up too much time here. Oh my gosh. It's hard to clip onto a 9-volt battery. Here, let me put it on this side. All right. So, let's see if we can get a spark for you. Nope, I didn't see it. But there's a lot of charge on there. It'll throw some sparks. We didn't get any sparks on that one, though. All right, so let's move along. And now, this is a symbol for a capacitor right here. This is the battery symbol. The long line is positive, and the short line is negative on the battery. Notice these are equal in length. When you hook this up to the positive side, electrons will come streaming off this metal surface, and it will become positively charged. On the other side, electrons will stream out, and then this side will become equally negatively charged. This is the symbol for a switch. This is when the switch is open, and this is a closed switch right over here. So the actual circuit diagram, and this is called a schematic, shows 3 capacitors, a switch, and the voltage of the battery right there. So when I lit up that light bulb a second ago, I was acting like the switch because I had the little conductor in my hand, the lead, and then I touched it right there and completed the circuit. So in this particular experiment you're doing this today, you're going to be using a switch, because the capacitor will charge up, and then you want to discharge it and not let the battery keep feeding charge. So you can open the switch and then take a lead from over here over to this side, and it'll short out the plates. All the positive on this side and the negative on that side will reunite and neutralize. All right, now this is the actual setup for your lab today. You're going to have 5 capacitors. 2 are going to be in what's called series. Series means one after the other. So the negative plate on this guy is hooked up to the positive plate, and then the negative plate over here goes back home. This is a resistor circuit right here, and actually this battery's reversed. So this is actually the positive side. This is the negative side. This arrow means it's a variable power supply. supply. And so on the table here, I have a power supply that is a variable power supply. So you can change the voltage. There's a switch right over here, and when we throw that switch, electrons will stream out here and fill up this side, and negative charge will be pulled over here and down here. So this will become positive, this will be negative, and then this will get polarized right here. Now these two capacitors are in parallel, and that means they share the same positive plate, and then they share the same negative plate. Notice this goes like this: positive, negative, positive, negative. But these are both positive on this side, both negative here, and then they're in series with that. And it'll be your job to measure how much charge is put on all these capacitors, what the voltage is across those capacitors, and then you're going to do the mathematics to make the mathematical prediction of what you would expect on these plates when you do that. All right, so the next slide shows if you've got two capacitors or more in series and you want to boil them down to one single capacitor so you can analyze the arrangement of the capacitors, you have to use this relationship right here. So 1 over CEQ equals 1 over C1 plus 1 over C2 plus dot, dot, dot. So if you have n capacitors in series, you would do this calculation right here. Now on your calculator, there's a button called X minus 1. And so what you do is you take the value of the capacitance and then you hit X minus 1 and it does this. And then you do and put in your C2 value and hit X minus 1 and it does that. You add them together, and then once you get your answer, then you do it again. You flip it over, X minus 1. Now when the capacitors are in parallel like this, the equivalent capacitance is real easy. You just add them up. And we're going to be studying that in more detail in class. Okay? Now, you cannot actually do the physical experiment, and we're going to show it to you here on the table, but you're going to be doing a simulation. So I'm just going to show you what the simulation looks like. But before I do that, I have to do one more thing. When the plates charge up, the capacitor plates charge up, there's current flowing from the battery to the plate. So dQ/dt is the rate at which charge is flowing through the wire. And then you saw that the light in the light bulb was very bright, and then it went down, 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 down until it was dark. So the current in the wire is changing as time goes by. Okay? So if you want to get the amount of charge that's put on a capacitor, you have to integrate the current over a certain time period. So if you take this equation right here, put dt over on the other side, and then integrate, you'll get the total charge on a capacitor. And we have infinity up here at the top, but it really doesn't take long. You see, we didn't wait infinitely long for that light bulb to go out. So for a capacitor, an infinite amount of time is maybe 10 seconds. Okay? So you're going to be doing that calculation for all of the capacitors in the circuit, and as well as treating the circuit as a whole capacitor called the equivalent capacitor, and then you're going to be measuring the charge on that equivalent capacitor for 10 different voltages. All right, and you're going to do all that in MultiSim. And in fact, this is your first MultiSim experiment. Basically, when you open MultiSim up, this is what it looks like. All right, that's what it looks like right there. And up at the top is a toolbar for picking off all the different components you're going to put on this breadboard right here. So they call that a breadboard. So when you hook this thing up, all these little dots in a real breadboard, you put the wires in a hole, and then they go into a conducting material, and then you hook that up. But here, this is what we're going to have. We're going to take a capacitor right here, just lay it out on the screen, and we're going to connect it with wires. So it actually looks like a regular circuit. So down here is a battery, And you can change the battery here by double-clicking on it. All right, this is a switch right here. Right now it happens to be closed, okay? And this measures current in the wire, and it's hooked up here to an oscilloscope, so you can actually see what the pattern looks like on the screen of the oscilloscope when you do it. Now the screen is over here, so when you thing, you get a screen where you can actually see what the flow of current looks like as a function of time. And it's looking across this resistor right here to see the current flowing, or actually seeing the voltage across that resistor. And then this measures the current flowing through that resistor and going out to all these capacitors. Okay? Now, when you do these circuits, you always have to have a ground. So there's a ground right there. So if you forget that and you try to run it, it'll give you a warning and say, listen, this circuit does not work right now because it doesn't have a ground. Now, you could also have a voltmeter, which you will have, and this is set for DC volts, and you see the V right here, and that's for this particular capacitor right here. So once your circuit gets all charged up with a certain voltage, you'll go around and measure the voltages on all the different capacitors by moving this thing from capacitor to capacitor to capacitor. And you're going to move this guy around and measure the current going to all these capacitors, and you'll have to do an integral to measure the charge that's going on those capacitors. All right? So this is the layout of MultiSim, and there's directions you're going to get on the lab sheet that'll take you step by step. And then when we have class, I'll be helping you out as well, especially this first time when you have to find everything for the first time. Okay? Anyway, this is what the curve on the screen looks like. So this current sensor right here is producing the green line, which you see right there. So by the way, you can right-click on these wires and change their colors. And then this red line is the voltage across that resistor. And you know, as the current's going down, the voltage is going down until it goes to 0. And then up here at the very, very top, I waited until it was fully charged, and you can see the voltage on that was 3.37 volts. The total voltage is 10 volts. All right, so that is it. That's the background to the experiment. And then what I'm going to do next is we're going to actually just show you the physical experiment that you would normally do, how you collect the data, and that'll be the video work that you can look at during the lab and also before the lab to prepare you for class. Okay.